All right, we're going to continue in our units on graphing linear style functions, and we're going to pick up on where we left off with absolute value. So the previous lesson, what we did was graphed some absolute value functions, and to refresh your memory, this is kind of what we came up with, knowing that the absolute value is going to keep everything positive, and if you were to make your table of values, the absolute value graph makes a V, and then something is going on with what's inside the absolute value bars and what's outside the absolute value bars, and I'll get into that in a second. But just to refresh our memories, that's kind of the basics of absolute value functions. As I'm looking at these two problems, this is kind of what we're going to have to get into graphing. I'm going to actually work on number 2 first, and to introduce a new concept called vertex form of absolute value. So we're going to get into a new concept called vertex form of absolute value. Now, just like we had with linear functions, we had some easier forms to graph from. If you remember when we were dealing with straight lines, yes, we had the table of values. We did that. But we also had the x-intercept and y-intercept that we could graph. And we also had slope-intercept form that we could graph. Right? So when we're dealing with straight lines, we could use the table. We could also use a couple other things. With absolute value functions, we can do something similar. So with absolute value functions, just like we showed in the previous lesson, we can make a table of values, but if our picture is not going to make a V, we've got some work to do, okay? Just like we showed in the last lesson. But there's also something called vertex form of absolute value. So vertex form. I would say very similar to slope-intercept form. Just in concept, you have a y, you have an x, and then everything else gives you information. It's the same thing with absolute value, but the vertex form looks really intimidating. So in vertex form, you do have a y, you do have an x, there's just a whole bunch of other stuff. Vertex form in absolute value looks like this. You have an a on the outside of the absolute value bars. You have an x on the inside of the absolute value bars. And then we're going to introduce 2 brand new letters to you. So this is called the vertex form of an absolute value graph, absolute value equation. And from that form, there are things that we can tell and then use it to help us graph. And this becomes a lot easier with practice. But this is vertex form. So now what we have to figure out, well, we have these new letters, this A here, this H here, and this K here. You know, some of us are still getting used to this M and this B. You're like, well, now I got more letters going on, so what's going on? So here's what vertex form gives us. First thing you need to know is what is a vertex. If you remember back in grade school, when you dealt with identifying, well, what is a triangle? A triangle is any shape that has 3 sides and 3 vertices, right? This is your vertex. In case of the vertex is, kind of the pointy part of the graph. And so, when you're talking about what is a vertex, we have to know, well, the vertex is that pointy part of the graph. And guess what? If we're dealing with absolute value functions, remember what our graphs look like. Hey, there's a pointy part of the graph. That's the vertex. Okay, so that pointy part is the vertex. By the way, pardon my sloppy vocabulary, but I want to make sure everyone is on the same page. So, what does vertex form give us? It gives us the vertex of the equation. It gives us the vertex of the equation. And the vertex is hk. So if your absolute value function reads x minus h, the vertex is positive h, comma, k, where h is the x-coordinate of the vertex, and k is the y-coordinate of the vertex. So yeah, there's 2 new letters, and it means there's 2 new pieces of vocab we have to know. But again, with practice, you're going to start seeing things become a lot easier. So the vertex is given to us. If it's x minus h, the vertex is positive h, comma, k. Now, what does the a do? What's that a doing out there? So the a gives us another piece of information. The a tells us about the shape of the graph. So the A tells us whether or not we're going to deal with a graph that looks like a V. You know what it can also tell us? It could tell us if the graph might be an upside down V. So the graph might make a V, or it might make an upside down V, depending on what A does. If A is positive, we'll have the graph go up like a V. If A is negative, the graph will go down like an upside down V. A also tells us another piece of information. A also gives us the slope of each of those line segments. So no matter what A was, if you look at the one part of the line, it gives us the rise over the run for that segment. So we can tell if it's going to be a V or an upside down V, and we can tell what the slope of that line segment or that ray would be. So A gives us some information. HK gives us some information as well. And so now what I'm going to do is take this information and apply it to our original equations. Actually, you know what? I'm going to apply it to the stuff we did yesterday. So take a look. Pardon the interruption.
Mr. Turley, please call extension 8741. Please call extension 8741. Thank you.
All right, thanks for your patience on that. Here was the equation that we graphed yesterday. And if you look here, if we pretend that this equation was in vertex form, okay, if we pretend this equation was in vertex form, you can see that there is no h in here. It's like x minus 0, right? And there would be no k on the outside of here. It would be like plus 0. So the vertex would be at 0, 0. And look at the picture. The vertex is at 0, 0. You can't see an A out in the front. You can't see an A out in the front. So it's like the A is 1, positive 1. That means it's opening up and a slope of positive 1. Rise 1, run 1. So we can even apply this to what we did yesterday. So how would this work with our two examples that we have here? So like I said, I'm going to go over number 2 first. So number 2, we have the graph of this equation, and we're going to sketch the graph. You can always use a table of values, but please remember, I want to use vertex form. And if you look at the equation, it's in vertex form. Just by looking at this equation, we can tell all sorts of neat information. Remember, vertex form gives us the vertex. If it's x minus h, then the vertex is positive h and k. So look at our problem. Inside the absolute value, we have x minus 5. So the vertex, the h, is going to be positive 5. So the vertex will have the first coordinate to be positive 5. From vertex form, the k, whatever's out there, goes here. And here in our equation, we have the minus 2 out there, and it's going to be minus 2 on the inside as well. So the vertex in our given equation is going to be 5 and negative 2. That is the vertex of the equation that we're looking at. Okay, so just by staring at that form and knowing how a vertex form looks, we're given the vertex. Now remember, there's that A piece that's out there as well. What does A tell us? Remember, A tells us whether or not we're having a V shape or an upside down V shape, and it's going to give us the slope as well. So look at our given equation. The A is going to be 2. And since A is going to be 2, since it's positive, we know it's going to make a V shape, and we know the slope is going to be 2, or remember how we describe slope as rise over run, up 2, right 1. And with that information, with this information, with the vertex and the slope, we can graph. So right now, we are able to graph. We have all the information we need to sketch this graph. So let's do that. Let's sketch this graph. And in general, we should know what type of shape this is going to make. Since it's an absolute value function, it's going to make a V. So let's make sure we know that. The vertex, remember the pointy part, is going to be at 5, -2. So here's 1, 2, 3, 4, 5, down 2. There's the vertex here. We know it's going to be a V shape opening up, and it has a slope of 2. Up 2, right 1. Up 1, up 2, right 1. Since it's a V shape, and this is the vertex, we know that it's going to look something like this. So we can make a third point. We can go up 2 and left 1 as well. So here's the vertex. We can go up 2, right 1, and we can go up 2, left 1 because it's going to make a V, and we know it's going to make a V. So we can sketch our graph. We can sketch our graph. From this equation, we can tell where the vertex is going to be and what the slope is going to be and what the picture is going to make. So we can sketch that graph. And that's how we can use vertex form in an equation. I want to do one more problem so we can get some practice under our belt. And then we should be able to graph any type of linear style function. So here's that first problem. Now remember, vertex form of a parabola. That a times x minus h plus k. If we look at this given equation, we can tell all sorts of information from it. The first thing we can tell is the vertex. Now, here's where things get a little bit tricky. Since the vertex from vertex form is hk, if it read x minus h, this would be positive h. Look at this. This says x plus 2. So what would the h in this example be? Since this is x minus h, positive h, this is x plus 2. The x coordinate of the vertex is going to be -2. That's where things get really, really tricky with vertex form. So you have to be careful. Since the k is plus k out here, this is plus 3. That's straightforward. The vertex is at -2, 3. And again, with practice, if you do your homework assignments, this is going to become a lot easier. We also know our a. And some of you are still afraid of fractions. We have to get over that. The a is -2/3. Since the a is negative, we already know what the picture is going to look like. It's going to be an upside down V because a is negative. It's going to be an upside down V because a is negative. And we also know the slope of -2/3. That means it's going to go down 2 and right 3. Okay, so all that information we can tell from vertex form, and we're ready to graph. That's all we need to sketch our graph. So we can do that. Okay, so here we start with our vertex at -2, 3. And so on our graph, we have -2, positive 3. That's where the vertex is. And from there, we know the slope is -2/3, or down 2, right 3. So from our vertex, we're going to go down 2 and right 3. And here's our next point. Since we know that this is going to make an upside down V, and this is the vertex, we could have another point, what's called a corresponding point, if we went down 2 and left 3, because we know it's going to make a V shape, an upside down V. So with all of this information that we know, we're able to sketch our graph. So our graph looks like an upside down V, because it's absolute value. We have that V-type shape. So all of that just from vertex form. Again, with practice, with the homework assignments, you should be able to become very, very good with this. And then we'll move on with newer material again later. Thank you.